like I have about another 5+ years of service. So, आप लोग anytime, those who are not visited CWPRS, please do come. How many of you have visited? Okay, 2. CWC both. Brahmaputra board. So you have visited, you have seen the physical models and all? Oh, very good, good. Okay, so yes, so I am going to give you a glimpse of about what I understood from this 1 or 2 days from Kunjir and what is being, as Director Nehri pointed out, we are the BOP, we are not the BOP, because the experience makes one a super boss. So Brahmaputra is one of the largest river, like those who work in Brahmaputra will be the bosses. The experience or the site challenges makes you a real engineer, right? So I believe in the concept. So it is a great opportunity that CWPRS has got working with Nehri, by which we could be able to handle such a unique and challenging task, by which our experience also, the field challenges are really going to be high. So I will just quickly, okay. So just quick insight into what CWPRS does. So to emerge as a global benchmark national center of excellence, that's our Vision 2047 statement of Ministry of Jal Shakti ko we have to, so that's what everybody is aiming at. So there are multiple agencies across India has to work on that task in developing the nation. So that's our common objective. So there are ways, we have some expertise, you have some expertise, and everything put together we go towards this. So CWPRS is now 110 years old. So Britishers have formed this institute. So this is a yes. Okay. So now we are 110 years. And with the vision statement, Britishers felt, and that time there was a need because your mathematical models or your computing capacities were not adequate enough to handle a complex problem. People were pointing out about turbulence, all so much of dynamic issues, right? Flood, erosion, silt. I think all these are like, you may call it is in your language, whatever you want, but these are all highly dynamic and ever time changing, time variant problems. So making this happen into a mathematical equation is going to be a big challenge, right? So and the computing facility, you need to have a supercomputing machine, right? Your equipments and your data has to be very large to have an accurate result. So this is a big challenge in your computing facility. In case if you have a supercomputing with so much of high performing GPUs, then you can go little closer to it. Otherwise, people always prefer to go for a physical model. So that's how the importance is justified, and physical model, and this will go hand in hand, by which you could be able to solve the natural problems. And this will give you a glimpse of the areas in which CWPRS addresses. So I'm not going to talk about everything. So we have a presence all over India, yeah. So you see that national committees we are members. What I have seen it, there may be a technology, but technology if we propose, people don't accept it unless otherwise that comes as a standard, right? So it is essential that the knowledgeable team has to be actively involved in editing or updating your standards as well. Jab tak it comes in the standard to say this is the way to do certain things in this way, people will go with the traditional technology, where I can quote an example of in a disputed sites, many sites, people still use current meters, right? There may be many other technologies, and current meters has a limitations at many instances, like a very high flow conditions, you cannot even enter the river. So they will go with the water level based measurements, right? But then if you take a velocity measurement and then give you the discharge, that is going to be more appropriate. But and the engineers always have a claim that, sir, this is not in a standard. So now the standards are also everywhere we are seeing there is an upgradation taking place, but then it has to be rooted in the proper channel. Then we are in NDSA, National Dam Safety Act. Once it is in place, there are mandates, and which is to be, I think how many of you are aware about the Dharma portal? None of you? Okay, so National Dam Safety Act is in place from 2021, which mandate certain things and which so much of data regarding the dam safety related issues has to be online portal. So this online portal name is Dharma. And there are certain things called as rapid assessments. You have to do it and then it has to be compulsorily uploaded. Maybe you will be coming across those things. So those who are part of some dams, you are expected to make this as a compulsory one. Okay, so this is the strength of CWPRS lies in the large land what we have, and we have a about good circulation water pumping system with enough adequate space for physical models, and we have the highest talented knowledge pool with about 30 years plus of experience. So this makes this institute so unique. So by this experience we could I don't call it as a BAP, we can be a brother. We are a brotherly figure to you, so that we can able to we can do a hand holding and take you along. And nowadays the challenges to CWPRS also high. Earlier what we were handling about maybe about 20 projects, now it has become 200 projects. The demand has also increased in all domains. So CWPRS is also at a big challenge, how to complete 200 projects in the same where we used to do 20 projects. So we need to optimize, we need to find out modern measurement methodologies. So CWPRS is also in the evolution of upgrading its technology to the next levels, right? So I think the physical models, other things our experts are going to cover, so I am not going to explain this. I am going to talk about only the technology part of it. Yeah, so here CWPRS addresses almost all aspects of water, which includes water quality. Even in dam health, probably now you are aware with NASA and Indian ISRO mission has created NISAR project, through which I don't know whether you are aware, you can able to monitor the settlement of a dam from a satellite data. In the range of even centimeters, you can able to measure the tilt, synthetic aperture radars. These are all in place, but we are not aware, because that is owned by a different department. ISRO owns it, but ISRO did it for some application, but then the information available through ISRO can be used. If you understand how this SAR technology works, you can use it for your structural monitoring as well. Settlements, tilt, in the range of they even climb millimeters level, but then centimeter level measurements with some pilot studies we could able to for Indira Sagar type of dams, we could able to get some measurements done. Then people talk about sedimentation, but most of the sedimentation monitoring is based on some assumption values, like even in Maharashtra, many places, because the measurement is going to be a challenge, right? People have technology today's world by which it is going to take about a reservoir of about 10 square kilometers, it's going to take about 10 to 15 days, right? And even if you do a sedimentation survey, it is going to change after some time, right? So this is mostly a challenging task of assessing your capacity presently. Many reservoirs, for that matter, in Madhya Pradesh, UP and all, they planned certain cities thinking that water supply will be available, but when they went and measured, that is more than 50% is silted up. Right now the challenge is how do you remove it. So these are all the other challenges. So CWPRS is entering into a challenging domain of assessing almost all reservoirs across India, all major reservoirs, and giving the actual sediment value by adding some sort of survey plus some satellite based imaging techniques. So which our Kunjir and the team went and presented to Honorable Minister on June, and then which is under the final approval stage. So that's a big responsibility we are taking. Then dam break, emergency action plan, these are all part of your dam health assessment and NDSA Act. Then river profiling discharge. So many of the flooding events, wherever it is occurring, even urban flooding or whatever flooding, you don't have the data, the ground data accurately validated, right? Mostly it is based on some assumptions, or you don't have actual cross-section data. Recently CWPRS is part of many of the major rivers in Godavari, some of the major projects, where it is a big challenge for our team to go and collect the cross-section profiles, right? Godavari type of river. I mean, Brahmaputra is much bigger. Like even in Godavari, about a kilometer wide river, you will have some island portions, some water portions. When you try to run the boat doesn't go in a straight line. When you try to pull an ADCP jumps out due to. So these are all the field practical difficulties. So finally you go with some sort of assumptions, right? There is a need today to have a quality data. So unless otherwise you ensure the quality data is collected, all the models whatever you are going to, so the junk in, junk out, like if you are, so all this artificial intelligence, everything fail because it is not the failure of the technology, it is a failure of what inputs you use, right? So always before getting into any of the modeling or any activity, ensure whether the data is accurate or to maximum. So you cannot get the 100% accurate data, but try to get as close as possible by applying the technology driven approach. Now the urban flooding related all works referred to us. Finally there will be a report and the problem is not solved. Again next year the flood occurs. Why? Because we say you get the data from the collector or somebody, and collector appoints an agency, he goes and collects the data by whatever, nobody has a quality control over it. So now once you produce an output and next year when the flood comes, what I will say, sir, the data what you have given is wrong or the data is not validated. So I have a scapegoat. So to avoid this, now ministry or our secretary level, what they feel is it should be a comprehensive approach. So data collection also should be part of the modeler's job, which is going to be a very big challenge, but then we don't have the expertise. So to overcome that, ministry themselves suggested us to empanel agencies and then get it done. So now we are working on that model. So any project if you give, we will be empaneling a person who will be under my supervision. So tomorrow I cannot blame the data quality, right? This is the approach, and we have to do it in a comprehensive way, right? For a MTech or a PhD level of or what you do, you take, because you have to publish a paper. So you will be very nicely apply your boundary condition and take a situation which matches your equation and your simulations or the developed model. So this also doesn't translate into your real world solutions. So there are challenges because the problem statement is itself is highly challenging. So to overcome that, but then you have to start as a piecewise, right? So these are some of the technologies. So and then CWPRS is working into canal automations, right? So discharge rating curves, our people will go and revise it. Presently they use ADCPs, and we have now come up with some innovative technologies for the interstate boundaries, which probably in the next slides I will be showing it. Then coastal area also CWPRS plays a major role. So many of the urban flooding, even a coastal is also, the tidal zone is also influencing. The cities like Mumbai, Surat, Gujarat, many of the places, the flood, the other part which is highly ignored portion. So you need to incorporate your tidal influx, wave characteristic, shoreline erosions, all those things, otherwise you cannot be able to deal with this, right? Then the controlling of any process, a communication technology, which recently we were fortunate enough to get a MOU signed with the ISRO, where SAC Ahmedabad is giving a separate transponder for your water resources applications. So the areas which are highly remote, where you cannot able to have a mobile or any network communication available. So ISRO will give you a small unit which is smaller than a mobile, which will directly link you to the satellite, and which will have a battery life of about 6 to 7 months or so. So once in 6-7 months somebody can go and, so your data, see, as I said, the data is inaccurate is one is you cannot collect, or even if you can able to put an instrument, you cannot able to get the data for your processing, right? Because those are very remote sites, but they are contributing to your flood or whatever process. So these are all the critical things. So that is also getting resolved with this ISRO agreement. Then SCADA is supervisory control and data acquisition. So connecting everything together in a central monitoring stations. If you see any of the NHPC type of projects, the complete process is very sensitive. From the dam top level to penstock vibration to power generation, the complete everywhere, if there is a small vibration created, the whole process can burst out. Even pumped storage schemes now. So how they are handling it, complete process will be monitored into one system, right, which is called as supervisory control and data acquisition. So this is a altogether concept by which, I mean, advanced countries like China, Japan, UK, they're all the processes are all monitored and controlled by the system. Only risk involved into this is there is it's all in a network. So an external agency can hack it. Say for example, you have a dam which is connected all through a network. Somebody can intervene into the network in case he can able to operate the gate. Right, so on those reasons we are not doing it, but that doesn't give you a comprehensive solution. So you need to have a secured network, plus that's what the next point is, secured network. Okay, so whatever I have covered on the first one, so this is technology by which you can able to do a survey. So I think you are aware, traditionally we take a boat and then connect an echo sounder and do surveys. So surveys can be multiple types: single beam, the synthetic aperture, multi-beam. So different ways you can able to survey the bottom profile changes, but this is again a manual method which is going to take time, and in case of the water turbulence, heavy flow conditions, you cannot able to run the boat. So at that time you have to, your models only can come for rescue. Okay, so this is again the survey part itself. Yeah, since this thing, I'll just quickly go through it. This theory parts I am not reading it. So I think our scientists will be covering about the physical models. I am not going to talk about it. So here you can see this sort of, this is a mathematical simulation. Here you can see arrangements of geophones. You have a transmitter, and then your phones can able to pick up structural, stability monitoring. I think you are aware about all these GPR, geophones, electrical resistivity imaging. You heard about these things? So okay. So CWPRS is into that domain also. So I am not here to teach you the whole thing. See, the coastal domain also we have very big model, but basically all these structures, all this type of larger models are in a position to operate because we have a larger infrastructure to pump in so much of volume of water, and then you need to have a circulation system. So this requires huge land, you need a lot of storage capacity, you need a circulation system. So this, I'm maintaining it. So worldwide, probably if you count, hardly 2-3 states will have such a facility. Now ARE is one among that. Yeah, but with the hand holding we will also grow together. And then once now things are getting automated in all means by putting so much of instruments, and for water level, velocity, water quality, everywhere we are going for some automations. Now a challenge comes. All these instruments have a calibration issues. I mean, in the sense whether your rain gauge, the amount of calculations it makes, whether it is right or not. So this type of challenges are being raised. So you need to have a calibration facility for all the, in case if you start using instruments, the instrument comes with a calibration certificate. So the calibration certificate normally is valid for 1 year or so. Some instrument only 6 months. So they need to get recalibrated with the reference numbers, right? So CWPRS is one of the institute where we have a calibration facilities, and somebody has to certify CWPRS, you are authorized to calibrate also. So there is an agency called as NABL accreditation, right? So NPL is an agency in New Delhi who is the father of calibration standards. So you take your instrument to them, calibrate it and bring it back as a standard. Otherwise they will come with their calibrated instrument, come and then check it against your reference. Then your water level measurement, you can say it is accurate, your velocity measurement is accurate, water quality, groundwater, whatever. So now CWPRS is, I think last year we have got the calibration certificate. This is, I think, the largest calibration facility for water resources related instrumentation. Like we have water quality, we have water level, we have groundwater, you have flow sensors. So our labs are calibrated under NABL accreditation. Okay. So here you see an automatic weather station, AWS. So all the parameters need to be calibrated. This is an ADCP, right? And yeah, this is a bathymetric echo sounder, GPS and echo sounder. Okay. And we are part of many of the national committees, so we know the real problems, so which our team keeps on updating into the standards as well, so that the standards get upgraded, so that everybody, the knowledge is shared. And we have signed a MOU with many institutes. Very soon we will sign one with Nihari as well. Yes. So I'll just get into, so now tomorrow we are going to Dimaji, because last time there was a flood, and then I think so many villages got washed away. You know what was the basic reason why Brahmaputra flooded last month? When the collector spoke to us, what I understood is the benchmark what was set up was having about 5 meters of error. 5-meter error in a Brahmaputra is going to cover up a larger area. So there was some justifications, but then now everything what you use is a GPS based referencing. You use J maps or your JA systems. Everything today you use it in your processing or reference to your GPS systems or GNSS system, Global Navigation Satellite Systems, right? The elevation what it gives is to be realigned, right? So today's instruments and technologies, you are using a data collection using a today technology, and your benchmark was established different, which you never bothered to. It is again a calibration, recalibrate it. And flat profile rivers, 100% you have to do it. At least vertical zones is 3 meters, probably everywhere that's an issue. So even urban flooding, most of the reasons were underestimated because their benchmark itself is, so you are expected to redo your land and your Bati surveys again with reference to re-established benchmark with reference to GNSS system. This is a mandate. Unless otherwise you doesn't do that, you cannot deal with a dynamic flooding situation. Your model, everything will be graphically appealing, but then you are making a basic error in your elevation itself. Okay, so so there are techniques today, so which was a challenging task earlier, but today is all possible with your drones. You know drone. Drones can able to, drone is a vessel which can be added with multiple payloads. So you can put a laser sensor, you can put a magnetic sensor, you can put a acoustic sensor, right? Everything has a different laser, a pointed source which can go and pick up your elevation in centimeter or millimeter level of accuracy. You can put a magnetic sensor which can able to penetrate below the earth and then go back and then get your reflections with reference to your magnetic properties. In case if you have reinforcements, it will have a different type. You can able to see the pillars buried below the earth, about 30-40 meters deep. Those features are available. NGRI Hyderabad did a helibound magnetron survey to find out the water level, the groundwater survey throughout the India, which has been an officially made map, helibound magnetron. Right, so there are technologies, but which technology to be used for what, at least those knowledge is required to have a quality input for us. And then for surveys, what we propose with the manually operated boat, nowadays you have an automated boats. You can put 2 latitude, longitude and draw parallel lines, the boat will automatically go and do a survey and come back. And you create a digital elevation model out of it. I'll show you some case study. So this was under a Dam Safety Act, we have did one dam in near to Pune. So normally this is all by a visual inspection. So far till last year, dams are inspected by a committee team of people who never even have an access to see certain places, gates, chains and this type of spillway portions. Whatever visibly seen, utna dekhe they used to make a report. Now this act was very, act has certain classes which you have to inspect every point, which is going to take about 10 to 15 days per dam. Now by flying a drone, I could able to see very closer details with the centimeter level precisions, and we could able to, even if you have a thermal sensor, you can able to find out the seepage. Even water need not come out. You can map your thermal profiling of an earthen dam and then say there is a seepage occurring, right? So beforehand itself you can able to take some remedial measures for the earthen dams, and say at the end of the survey you could able to produce a 3D map out of it. So this is a echo sounder which has surveyed the bottom portion of it, right? So yeah, so these are all quite fast. So actually this particular reservoir, it took about 15 to 20 minutes. So that is the speed in which we are talking about. And in case if you are talking a scale of about 2000 reservoir across India, you have to deploy about 10 teams of this technology, and you should be able to get it in a timeline of an year or so, or 2 years maximum. You can able to get it done. We are getting in that lines. Okay, so this and this is a technology what we demonstrated for Honorable Supreme Court members and Kaveri Dispute Tribunal team, where we demonstrated, whereas in this site, this is in Jala site where it is an installed technology. Camera, so this is a camera. This camera can able to, it is fed only with the cross-section profile once surveyed, and it can able to give you the velocity as well as discharge. So in cases where you cannot able to access the flow by a boat or a technology, this is a very promising technology. Japan and German, these are all patented technologies, so they use it on a very large scale. Now we are also bringing. Here this is at Kaveri dispute site between Tamil Nadu and Karnataka. So I was part of this study. We were not even aware of what width, everything. We just put a camera here, and then it has given the average velocity, maximum velocity and discharge. And it was exactly matching with what Central Water Commission has. They came 2 days in advance, they did a profiling, and then they used current meters, and then 2-3 days they calculated. And then this was like it is a regatta, national regatta, like a competition sort of thing. So this is also getting as a popular technology nowadays. So anyway, I'll not. And then for earthen dams, CWPRS rejuvenate also, like the existing the seepage and uplift pressure. Many of the dams, almost 90% of the dams in India, instruments maybe were put, but then none of them are working, or none of them were monitored. So we are into the process of rejuvenating them as well. You can go through the other things. Actually, these are all pump intake studies and all. This is our canal automation lab at CWPRS. ADCP has been pulled out. Current calibration. I think I have already touched upon all those things. Then our geotechnical team and geophysical. So you have a complete gamut. What CSMRS is also almost, they are also doing similar thing. Then vibration technology, engineering seismology. So CWPRS has developed a software for for northern part of India, and which we are trying to integrate with IIT Roorkee to make a combined seismic hazard mapping software, which will be ready soon. And then a new advanced technology recently what we have identified the area is fiber optic sensing. In case if a structure which is already existing where there are no instruments, you can still put some fibers. Fiber is an optical cable where light will pass and which can able to measure temperature, stress, strain and pressures. One cable and continuous measurement, any point. It is not like you put here, it is a continuous measurement. So which we proposed it for Jharkhand, but DRIP officials asked us to put it in Maneri Dam. So very soon the funds will be released and we will be doing this. Then you need to incorporate a lot of AML based forecasting models and all. But of course, first let us start with simple modeling. But all these models depends upon your data quality, right? So finally, it's all end up in your data. Yes, so even the physical model measurements at CWPRS, it is 12 now. Okay, so basically, let me conclude it. CWPRS is like maybe 100 years we have been using physical models. So the physical model also has a measurements, right? You scale it down, so the measurement has to be highly precise. When you scale down a process into like 1 into 100 times or 400, 500 times, your measurement of a meter will become a millimeter here. So you need to have a technology which can able to pick up the process so precisely. So when you take a physical model study, you have to take utmost care. So now when you try to pick the process by putting a sensor into water, you are actually disturbing the flow because of the scale versions. So this type of observations were made. So you have to put in lot of factor of safety, right? So for example, if you have to make in a coastal structure a guide bund, instead of 1 meter you will say 3 meters, because you have an inaccuracy in your measurement, right? So it is always preferable to measure it without touching the process. So these non-contact type of measurements are all becoming very popular. So anyway, so CWPRS would like to join hands with whoever interested, and we are going to handle more projects by joining hands. Then secured SCADA is the next targeted. I think now you are not aware about this, but all the Dam Safety Act, we need to get into SCADA with the secured SCADA. For any of your doubts, please write to director@CWPRS. And please visit CWPRS website www.cwprs.gov.in, where we have a lot of videos, course materials, technical memorandums. Please go through it. They will be very helpful for your research activities as well. So with that, I'll thank you so much. Yeah. Right. Okay.